Good morning students. So in previous video we know what is the classless interdomain routing. So basic difference between the classful and classless. In classless we have to choose between the class A, B and C for our organizations for creating the host ID. But in classless it is the prevention that you just take how many hosts you want, you just take that exact value and no host will waste for the creating the our host ID for the organizations. Okay, the basic difference is classless and classful is there. Okay, so it is also a 32 bits IP address according to our same as the our classful IP address. It is also a 32-bit address which includes a special number which represents the number of bits that are present in the block ID. New word will come in classless is block ID, and block ID is working as your host ID like the IP address also in the 32 bits. Okay, so rules. What are so many rules are there for creating the CIDR? So rules 1 is all IP addresses must be contiguous. Contiguous means like 0, 1, 2, 3, 4. No, never a single bit or single number will be left. So it is the continuous process. Next, rule 2. Rule 2 is your block size must be power of 2 to the power n. So like 2 to the power n means 2 to the power 2 or 2 to the power 3, either 2 to the power 8. So every bit is divisible by the 2. That is the main point, is every bit is divisible by the 2. That is the block size must be 2 to the power n. And the last rule is number 3. First IP addresses of the block must be evenly divisible by the size of the block. Remember, first IP address of the block must be evenly divisible by the size of the block. Okay, this all about your CIDR notation, which is known as the classless interdomain routing, and which is the creating on the basis of the disadvantage of the classful addressing scheme. Okay, let's go for the next. Next is your ISP. So ISP stands for Internet Domain Service. ISP is stand for the Internet Service Provider. It is a company. ISP is a company. ISP, Internet Service Provider, is a company which provides internet connection to end user. End user means us. But there are basically 3 levels of ISP. There are 3 levels of internet service provider: tier 1, tier 2 and tier 3. So in this IP means in this internet service provider architecture, first is the tier 1. These ISPs are at the top of the hierarchy. This is the hierarchy tree and this is the top of the hierarchy, and they have a global reach. They do not pay for any internet traffic through their network inside. Lower tier ISPs have to pay a cost for passing their traffic from one location to another, which is not under the reach of that ISPs. Generally, ISP at the same level connect to each other and allow free traffic passes for each other. These So these ISPs are known as the peer-to-peer connection. Next is go for the tier 2. So tier 2, This ISP is a service provider who connects between tier 1 and tier 3. See, it is the combination, it is the connection between the tier 1 and tier 3. They have regional or country reach and behave just like tier 1 ISP for tier 3 ISP. Next, go for the tier 3. These ISPs are closest to the end users and helps them to connect to the internet by charging some amount. These ISPs work on purchasing model. These ISPs have to pay some cost to tier 2 ISPs based on traffic generated. So these all about our ISP. So basically, what is the meaning of ISP? ISP stands for Internet Service Provider. It is a company which provides internet to us. We are using internet in day-to-day life, in the daily basis, we are using the internet daily. So for that we are paying some cost. So we are in the tier 3 position. We end user are in the tier 3 position. So tier 1 is our Tata company or many more companies there who are providing the internet to us. Then this is the ISP's company who are providing the mini ISP companies. So in tier 3 companies are giving internet to our us or to the public. For that they are charging some amount and providing the internet. So this diagram is about your ISP, Internet Service Provider hierarchy. This is the hierarchical tree, and basis the depending upon this diagram, we are getting the internet from our ISPs, from our company. These are all about your the ISP, and we go for the next slide. In the next slide, we know about what is TCP/IP. What is the TCP/IP model? TCP/IP model was developed prior to the OSI model. The TCP/IP model is not exactly similar to our OSI model. The TCP/IP model consists of 5 layers: the application layer, the transport layer, the network layer, the data link layer, and last one is your physical layer. First 4 layers provide physical standards, network interface, internetworking, and transport functions that correspond to the first 4 layers. And these 4 layers are represented in TCP/IP model by a single layer called application layer. TCP/IP is a hierarchical protocol made up of interactive modules, and each of them provides specific functionality. So let's go what is application layer. An application layer is the topmost layer in the TCP/IP model. It is responsible for handling high-level protocols issues of representation. This layer allows the user to interact with the application. When one application layer protocol wants to communicate with another application layer, it forwards its data to the transport layer. This is an ambiguity occurs in the application layer. Every application cannot be placed inside the application layer except those who interact with the communication systems. So, the first purpose for the application layer is that application layer is direct contact to the end user like us. So what is the requirement of the user? It decided by the applications layer, and it decide what the output they require. According to that, it decide what to do in here. This is the application layer of the TCP/IP model. and same as the application layer is present also in the OSI model. This is all about your application layer.